Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel A level paper from 2018. This is paper 1 and we're on question 5, and if you'd like to see the rest of the questions, please hit the subscribe button below. So question 5 is a question about differentiation, and we've got an expression here which is a trigonometric expression, and so we can also see that we've got a quotient. So we've got to understand some of the rules that we're going to use for this. And the first one that we need to know is we need to know how to use the quotient rule for differentiation. So I'm just going to write that down first of all. So what I've written here is that if y is a function of x, which is u is a function of x here, and v is also a function of x, and they're in the form of a fraction, then if we was to differentiate that to get dy dx, then we've got a formula here which is saying that will be equal to v times the differential of u, the top one here, with respect to x, minus u times by the differential of the bottom of the fraction, so dv dx, and then all divided by v squared. So in our case, we actually have got that, but we've got, instead of it being a function of x, we've actually got a function of theta. So our variable, instead of being x, is actually theta. So we've got that y is actually, again, a function of u. U is a function of theta, and v is a function of theta. And in our case, u is equal to 3 sine theta, and v is equal to 2 sine theta plus 2 cos theta. So the first thing that I'm going to do in order to apply it to this formula here is I'm going to differentiate both of these to find du d theta. If I differentiate the top one, if I do that, du d theta is going to give me, if I differentiate that, I'm going to get 3 cos theta. If I differentiate v with respect to theta, then what I'm going to get is, I'm going to get 2, and then the sign's going to differentiate to give cos theta, and then I'm going to get 2 minus, so I should just rub that out because that's going to be a minus there. Rub that out. So take away, and then 2 sine theta, since cos theta differentiates to give minus sine theta. So that's the information I would need for the top part of this this formula here. But to work out the bottom part, I'm going to have to square v. So since v is 2 sine theta, 2 cos theta, and then I'm just going to actually factorize that first of all, just to make it a little bit easier. So I'm going to say that's 2 sine theta plus cos theta. And if I want v squared, then it's going to be, okay, so just squaring the 2 at the front there, and then squaring the bracket. So I'm squaring sine theta plus cos theta. So I square that. So if I square out the brackets there, I'll get that v squared is equal to the 4, which I already had. And then I'm going to get sine squared theta plus cos squared theta. And then I'll actually get 2 sine theta cos theta. And just to tidy that up as well, before going any further, I'm going to use the identity that we should know at this stage, which is that sine squared theta plus cos squared theta is equal to, because it's an identity I can use a triple equals there, is equal to 1. So the sine squared theta plus the cos squared theta is going to simplify to just being 1. So that means that v squared is going to equal 4, and then in the brackets I'm just going to have 1 plus 2 sine theta cos theta. Now that will simplify further. It's probably useful to do it at this stage by using another identity, which is our double angle formula. So we've got sine 2 theta equals 2 sine theta cos theta, and we can replace our 2 sine theta cos theta then in our expression for v squared by putting sine 2 theta. So actually v squared is equal to 4, and then in the brackets 1 plus sine 2 theta. And that's good because it's starting to look like the bottom of this this equation that we're trying to find. So if we now substitute it into our formula at the top here for the quotient rule, this one, we're going to replace the v there by 2 sine theta 2 cos theta. So we're going to get dy dx is equal to 2 sine theta cos 2 cos theta, and I'm just going to factorize that just to make life a little bit easier. So I've got 2 sine theta plus cos theta, and that's going to be multiplied by the result of du dx, or in our case du d theta. So that's going to be times by the 3 cos theta. I'm going to subtract from that Ru, which is the 3 sine theta. Just make a little bit of space here so we can carry on with this. So we're going to multiply that 3 sine theta by our expression for dv d theta, which is this 2 cos theta minus 2 sine theta. So again, I could refactorize that as well. I could make that 2 cos theta minus sine theta, just make it a bit easier when I put it into this. So that's going to be times by 2 cos theta minus sine theta, and it's going to be all over the 4 1 plus sine 2 theta. So this is just a lot of tidying up now. So I've just moved the board around a little bit just so we can see a bit better what we're doing. So we're just going to try and multiply out these brackets just to tidy up what's on the top line here. Everything's needing quite a bit of tidying up to get to what we need to get to. So I'm going to multiply the 2 and the 3 together, just to give us a 6 at the beginning, and then open up a bracket. So 6 sine theta times the cos theta, sine theta, cos theta. And then we've got cos theta times cos theta. So that's going to be plus cos squared theta. And I'm going to do the same here. So we've got the 3 and the 2 and the minus there as well. So it's going to give me minus 6. And then I'm just going to multiply into this with a sine theta then. So I've got sine theta times cos theta is going to give me sine theta cos theta. And then we've got sine theta times minus sine theta, which is going to be minus sine squared theta. And we've got to be very careful with signs in all of this. So I'll just rewrite what I've got on the bottom line there, which is the 4 and then the 1 plus the sine 2 theta. So if I tidy this up further, I can see I've got a 6 sine theta cos theta and take away 6 sine theta cos theta. So I can just cancel them off. So that's just going to tidy things up a lot more. So then I've got, just multiplying this bracket out again, I've got 6 cos squared theta. And then I've got minus 6 times minus sine squared theta. So that's going to be plus 6 sine squared theta. And then that's still over the 4 1 plus sine 2 theta. And then I can factorize the top line there, and I'm just going to change the order of the sine squared and the cos squared, just so it's in a more familiar form. Sine squared theta plus cos squared theta all over this again. And we're nearly there. We should be really crying out to us that we've got an identity here, which is sine squared theta plus cos squared theta equals 1. I can use triple equals because it's true for all values of theta. So that's going to disappear what's inside the brackets. That's just 1 inside the bracket. What that means is that we've got just 6 on the top over 4, 1 plus sine 2 theta. And we're very close to the final answer. If we just can't simplify this, that's a 3, that's a 2. And so that would be actually 3 over 2 over the 1 plus sine 2 theta. And because we were looking for it, if I just go back up on the board there, because we were actually looking for the value of A here over 1 plus sine 2 theta, we can see that we've done it, because you can see here that A is actually 3 over 2. So that's it. A is 3 over 2, or we could say 1.5. And it did say at the beginning that A is a rational number, and I didn't mention, so a rational number, which we should know from GCSE, is something that can be written as a fraction like that. So an example of a non-rational would be something like root 2 is non-rational. But we've got a rational number, so that would be a non-rational, but this is rational. So that's it. So I hope that was helpful to you, and if it was, please like our video and hit the subscribe button to see more of our videos. Thanks for watching.